Well, hello. The purpose of this video is just to give a quick overview of the Newton's law of universal gravitation and also to give you the world's best pickup line if you ever should need it. So I'll give you that world's best pickup line at the end of this video just to encourage you to watch the entire video. All right, so what I would like to point out is primarily this equation right here. And this is, I've got it circled in blue. This is Newton's law of universal gravitation. And what Newton says is that the force of attraction, and this would be the gravitational force, between object and right here, we call that object M1, and object 2, M2. The force of attraction between those two objects is equal to the gravitational constant, which is just a tiny number. Trying to see if they show it here. They do not. It is 1.67 times 10 to the negative 11, if I remember properly. All right. I double checked myself and it wasn't 1.67. Sorry. It is in fact G is equal to 6.67 times 10 to the 11th. So we have the force of gravity between two objects is equal to G, which is a teeny weeny number, times the masses of the two objects multiplied by each other divided by the radius or the distance between them squared. Now, we normally think of gravity, most folks probably think of gravity as this thing that happens between us and the earth. And so normally there would be something like if this was the earth and you're standing on the earth, you're really big. And in fact, there is this force of attraction between you. And it's a result of the mass of you and the mass of the earth. And this distance between you and the center of the earth and the center of you would be this called this radius, or that we would just think of it as a distance. And we could calculate the force of gravity on you would be equal to the mass of the earth times your mass divided by the distance between the center of you and the center of the earth squared, multiplied by this tiny number. And this is in fact useful, and often that's the way we think about it. But it's also worth noting this also affects, say, two planets. So this could actually be the moon, this could be the moon, and this could be Earth, and there's a force of gravity between them. Now notice this force is exerted in both directions. You're pulling, there's a force of attraction on you, you're pulling on the Earth with the exact same force that the Earth's pulling on you. It's kind of, think of it as like a rubber band or a cable between you. It's not like the Earth is pulling on you, but you're not pulling on the Earth. That would go back to Newton's third law. Now, why is it that you move, unless you're Chuck Norris, but why is it if you jump up, you come right back down, or if you jump off of a ledge, you come down to the Earth? Well, the Earth is so big, it's not really affected by that force in a measurable or a noticeable way. Say you have the moon and the earth here. This is a little bit of a different scenario. In fact, when you have the water on the earth, it's all being attracted to the moon. When the moon is on this side, in fact, the water on the earth does shift slightly that way because it's really the only part of the earth that can move much. And the water or the oceans do shift towards the moon as a result of this gravity, and that's of course what tides are. Now, I did promise you the world's best pickup line. And so here we go. Here we go. You ready for this? All right. So the world's best pickup line. Did you know that according to Newton's law of universal gravitation, you are attracted to me? There you have it. And now, of course, why can we say that? Well, if you have mass, I should probably delete all of this stuff. This is getting pretty clunky here. Why does that all work? Well, according to this is the law of universal gravitation, and if you have mass, and you do, trust me, and any other person in the universe or any other object in the universe has mass, and trust me, they do, there is a gravitational force of attraction between those two things. And so it is safe to say that according to Newton's law of universal gravitation, you are attracted to me. And you can show that significant person that you're both witty and brilliant, and you're sure to get whatever it is you're wanting in terms of that pickup line. Another cool thing to point out is the connection between these two equations. Check this out. This one is gravity, which is one of the fundamental forces of the universe. And this one is the force of electrostatic attraction. This is known as Coulomb's law. Don't these look so similar? Check it out. There's a force, there's a constant. This constant's a gigantic number. This constant was a tiny weeny number. But then we have two different things that are being multiplied by each other, and then the radius between them squared. And so this electrostatic force is also a fundamental force of the universe. And isn't it interesting how similar these two equations are? And we've already learned about this, but if we haven't, this is just called Coulomb's law. And obviously we'll talk about that at some point. Thank you. Hope you learned something here. Like and subscribe.